Hi guys, so this is topic one, lesson two, example two for algebra class. I wrote that up here, topic one, lesson two, example two, so you can see that. And this involves creating your own equation before you actually solve your equation. So one of the questions that we're going to take care of here are consecutive integers. And there's a few words here in math that you need to know before you actually get started so we understand what in the world we're actually talking about. So we got to take words and we got to create math out of those words. And most of the time it's very easy, and I'm going to try to make it as simple as I can for you. So first we have the sum. Sum means we're going to add things together. We're going to add three consecutive integers. Consecutive, guys, means one after another. That doesn't necessarily mean that it's always going to say like the numbers one, two, three, they're right in order. They could possibly say three consecutive odd integers. So, for example, three consecutive odd integers might be 3, 5, 7, because those are the three consecutive odd integers. And it could be the same thing for even integers. So you have to really pay attention to how they word this. In this case, it's just three consecutive integers. So I know it's just going to be three numbers in a row that add up to, because of the sum, the number 132. Remember that consecutive means in a row. That's a word that often eighth grade students have a hard time with. And integers is one of the numbers that you have to understand. They are whole numbers, and they are positive and negative. They include zero as well, but they can be negative and they can be positive. So there's three numbers, negative or positive numbers, three integers, that if I put those three consecutive ones together, they're going to give me a value of 132. Is in math class, whenever you're trying to create an equation, is a very good indication that that's where the equal sign belongs. Okay, so the very first thing we got to do is we have to select what is the number one thing we don't know. Well, we don't know all three integers, but the one that we really don't know to start with is actually the first integer. We don't know what the first integer is in order to grab three integers, throw them together, and get 132. So I'm going to assign a value to these variables. So I'm going to call x our first integer. I'm going to be specific with that, because here's what I can do if I know that the first integer, which I don't know what it is, that's why I call it x, I can create for myself the second integer, and I can also create for myself the third integer. There's three integers, and they're all consecutive. So here's what I got to do a little bit of thinking on. If I say my first number is x, then I know that the second number is whatever the first number is plus one more. So that is the x plus 1. And if I want the third integer, I could take my x again, and instead of being x plus 1 to get there, this would be x plus 2. So here are my first three integers. They look weird because they're expressions. My first integer is x. Don't know what it is yet. My second integer, I don't know what it is either, but I know it's one more than the first integer, and the third integer I know is two more than the first integer. But I know that all three of these are going to add together to equal 132. So this is where I now create my equation. And here's the equation. X plus x plus 1 plus x plus 2 equals 132. Here's the first integer. Here's the second integer, x plus 1. And there's the third integer, x plus 2. If I add them all together, I should get 132. Now, I'm going back to to our first example and solving equations. Here's what you have to know about solving equations. Are both sides simplified? This side right now is currently simplified. It's 132. I mean, we may have to add something to it or subtract it, but right now it's okay. This side is not simplified. This expression over here, we have some things called like terms that need to be combined. And I know you learned that last year in seventh grade and possibly in sixth grade as well. So the terms that I have to combine are my variable and my constants. My variables that go together here with a little bit of invisible math is 1x plus 1x plus 1x. That gives me 3x. My constants that I'm allowed to put together are positive 1 positive 2. Notice I said put them together. If I have one positive and two positives, I get three positives. That helps you out a lot whenever you're solving these equations. So this is plus 3. My equation is now simplified on both sides. This expression, 3x plus 3, is simplified. That equals 132 simplified. Variable constant and just a constant. Good. We want to get the variable all by itself. So the first thing we want to get rid of when we get the variable all by itself is the constant. We don't want the constant to be any part of this variable. So undo addition. In order to undo addition, we'd have to do subtraction. But if we subtract from one side, we always have to subtract from the other side. So this side is going to say 3x plus 3 minus 3. And this side will say 132 minus 3. So here's your positive 3 and negative 3. So if I have 3 positives and 3 negatives, they wipe each other out. They're gone. So I end up with just a 3x. And if you have 132 and you subtract 3, you'll end up with the number 129. Okay, now, notice I said undo the addition. You also have to undo this next expression. This is a multiplication expression because a 3 and an x, 3 is getting multiplied by x. We don't know what x is, but it's multiplication. So to undo multiplication and get rid of the 3, we have to do division. It's the inverse operation of multiplication. You undo multiplication, we use division. So I divide this side by 3, but remember in an equation, if you divide one side by 3, you got to divide the other side by 3. So this is nice and simple. 3 divided by 3 is 1. So I get 1x. Notice I don't write my 1 because that's part of invisible math. It's part of us just being more simple in math. But if I do 129 divided by 3, some people may be able to do that in your head. You go right ahead and do that. That's okay. If you can't, this is how you solve that. Here's 129 divided by 3, old school. 3 does not go into 1, so the first largest number that it goes into is 12. 3 times 4 gives me 12. 4 times 3 gives me 12. If I subtract, I get 0. 0 is lower than 3, so I know I'm okay. I bring down the 9. Here's my new division problem. 9 divided by 3. 9 divided by 3 will give me 3. So I know that x equals 43. Now, this only tells me what x is, but it doesn't tell me the 3 integers. Okay, it only tells me the first integer because x is the first integer. So I know that the first integer is 43. The second integer is 43 plus 1, which will equal 44. And the third integer is 43 plus 2, which gives us 45. And if you take those 3 numbers and you apply them to the simplified version that I talked about last time, which was right here, you can say 3 times 43 is equal to 129, and 129 plus 3 is 132, so they're both the same. If you take these 3 consecutive integers and you add them together, 43 plus 44 plus 45, you will again get the number 132. That is how you solve consecutive integers, but be very careful because they are not always going to be 3 in a row consecutively just as integers. You may have odd integers, you may have even integers, you may have multiples of 5. You never know what they're going to talk about, so you have to be very, very careful reading the questions to give you a very, very specific answer. Okay? If you have questions, we can do that in class. You should be able to take care of try it with this and figure out some of these consecutive numbers. Look back at the video if you can. That's why I create them, guys. Good luck. If you need anything, please email me and I can help you out.